Hello everyone, welcome to the lecture series on computer architecture and organization. In this lecture, we are going to see about the first topic under Unit 4, that is memory and IO organization. So this is all about what we are going to discuss in this chapter. Ideally, one would desire an indefinitely large memory capacity such that any particular word would be immediately available. We are forced to recognize the possibility of constructing a hierarchy of memories, each of which has greater capacity than the preceding, but which is less quickly accessible. So this is the analogy that illustrates about this memory hierarchy, how we are fetching the information from the memory. Suppose that you were a student writing a term paper on important historical developments in computer hardware. You are sitting at a desk in a library with a collection of books that you have pulled from the shelves and are examining. You find that several of the important computers that you need to write about are described in the books you have, but there is nothing about the exact. Therefore, you go back to the shelves and look for an additional book. You find a book on early British computers that covers the exact. Once you have a good selection of books on the desk in front of you, there is a good probability that many of the topics you need can be found in them, and you may spend most of your time just using the books on the desk without going back to the shelves. Having several books on the desk in front of you saves time compared to having only one book there and constantly having to go back to the shelves to return it and take out another. So the same principle allows us to create the illusion of a large memory that we can access as fast as a very small memory. Just as you did not need to access all the books in the library at once with equal probability, a program does not access all of its code or data at once with equal probability. Otherwise, it will be impossible to make the most memory accesses fast, and still we desire to have a very large memory in computers. If you see about this analogy here, keeping all the books in your desk and you make a desire to search for the interest of your book very quick, then it is impossible. So if you see here, this speaks about the principle of locality. This is nothing but how we have accessed a very small portion of the library's collection. Likewise, the program will also access a relatively small portion of their address space at any instant of time. So this principle of locality underlies both the way in which we did our work in library and the way that programs operate. So there are generally two types of principle of locality. One is the temporal locality and another one is spatial locality. So what is this temporal locality? If we speak in very brief, if an item is referenced, it will tend to be referenced again soon. So if you recently brought a book to your desk to look at, you will probably need to look it again soon. Similarly, for this spatial locality, if an item is referenced, items whose addresses are close by will also tend to be referenced soon. For example, when you brought out the book on early English computers to find out about the exact, you also noticed there was another bookshelf next to it about the early mechanical computers. So you also brought back that book and later on found something useful in that book. So libraries put books on the same topic together on the same shelves to increase the spatial locality. So we will see how this memory hierarchies use the spatial locality and this temporal locality a little later. So if you see here, this is about the basic structure of this memory hierarchy. The memory which is close to the processor will be the fastest and smallest, and the memory which is farther from the processor is very slowest as well as it is biggest. So by implementing this memory system as a hierarchy, what is the advantage in the sense? We have an illusion of a memory that the memory is as large as the largest level of the hierarchy, but it can be accessed as if it were all built from the fastest memory. It means that though we access some content from this memory, Then by implementing this hierarchy, the information we are accessing from this memory will not be like the information. Actually, what happened is that the information we are fetching from this memory is very farther, but the speed will be very slower. But implementing this memory hierarchy will pose the user that as if the information has fetched from the fastest level, that is the memory level, which is closest to the processor. So this is the basic advantage of implementing this memory hierarchy. So what is memory hierarchy? So we take advantage of the principle of locality by implementing the memory of a computer as a memory hierarchy. So a memory hierarchy consists of multiple levels of memory with different speeds and sizes. The faster memories are more expensive per bit than the slower memories and thus are smaller. So what is a memory hierarchy in the sense? A structure that uses multiple levels of memories. As the distance from the processor increases, the size of the memories and the access time both increase. So if we see here, this is the pair of levels in the hierarchy. So a memory hierarchy can consist of multiple levels, but data is copied between only the two adjacent levels at a time. So we can focus our attention on just two levels. If you take this, this diagram has the processor and this is the memory hierarchy. The memory hierarchy, this is the upper level and this is the lower level with respect to processor. So how can we say this is an upper level? The level that is closer to the processor is termed as upper level and the level that is a little bit farther from the processor is lower level. Or we can say that each and every level has an upper level and a lower level. So upper level is always faster and the lower level is always slower. So now we have come to the point. What is the use of this memory hierarchy? So the goal is to present the user with a very large memory. If we are in need of large memory, but creating the large memory is very slower in conveying the information to the processor. But we are in need of both the things. One thing is that we need to access the memory very fast, as well as the memory should be very large. So this memory, if we fetch an information from this memory should also be very large, as well as the memory should be accessed very fast, as with the level that is very close to the processor. Okay. So whatever the information we are fetching, that information is called as a block or a line. In a library analogy, a block of information is nothing but the book we are searching for. So before getting into this, we need to be very familiar with some terminologies that is associated with this memory hierarchy. So if a data is requested by the processor, appears in some block in the upper level in the sense that this is the upper level with in this diagram because this is just farther away from this processor. So if the data is being requested by the processor that appears in some block in the upper level, it means that some data are residing in the upper level, then that is called as a hit. Okay, that is analogous to finding the information in one of the books on our desk. So if the data is not found in the upper level, then the request is called as a miss. The lower level, if the miss happens, then the lower level in the hierarchy is then accessed to retrieve the block containing the requested data. That is, continuing our analogy, you go from your desk to the shelves to find the desired book. So this is nothing but the block, the minimum unit of information that can be either present or not present in a cache. What is hit rate? The fraction of memory accesses found in a level of the memory hierarchy. What is miss rate? The fraction of the memory accesses not found in the level of the memory hierarchy. And these are very important, that is hit time and miss penalty, because the performance is the major reason for having this memory hierarchy. The time to service the hits and misses are very important. So if we speak about this hit time, the hit time is nothing but the time required to access a level of the memory hierarchy, including the time needed to determine whether the access is a hit or a miss. So this also includes the access time as well as the time required to access a level of the memory. If the information present then it will access the memory. So that time, that is the accessing time plus the time required to search the information in the memory hierarchy or search a block in a memory hierarchy, both time gets added together, and this presents the hit time. And what is miss penalty? The time required to fetch a block into a level of the memory hierarchy from the lower level, including the time to access the block, transmit it from one level to the other, insert it in the level that experienced the miss, and then pass the block to the requester. So this is miss penalty. So we can say that the analogy for this hit time and miss penalty can be given by, for the hit time, it is nothing but the time needed to look through the books on the desk. For miss penalty, this is the time to get another book from the shelves and place it on the desk. So this is the structure of the memory hierarchy, and this is a CPU, that is the processor. And if you increase the distance from the CPU, also the access time is also increased. And this is the size of the memory at each level. If you find at the top, the size of the memory will be very less, but if you find at the bottom, the size of the memory is very large. So the memory is very large, but the information or the access we are fetching, the time to fetch the information or the access time is very low. Here, if we see, the memory is very small, but it is very fast. We are in need of both the advantage, that the memory should be large as well as fast. So that's why we are going for this memory hierarchy. So recalling back this, what is hit and miss? What is a hit in the sense, if we find any block in the upper level, that is the level that is closer to the processor, then that is called as a hit. Block in the sense, block is nothing but the information. What is a miss? If we can't find any of the block or information in the level 1 what we are searching for, then we must replace any one of the block in the level 1 from the lower level where the information is placed. Nothing but we are replacing a block in the upper level with the informations we are being fetched from the lower levels. So these are all the process that happens when a miss occurs. Miss in the sense, no, the absence of information in the upper level. So we saw about what is miss penalty. Miss penalty is the time that is needed to replace the block in the upper level with the information of the lower level, as well as the time that includes that included by the processor to fetch the information from the upper level. So this is about the miss penalty. So what is the use of this memory hierarchy? By constructing this type of memory hierarchy, this structure with the appropriate operating mechanism, this allows the CPU to have an access time that is determined primarily by level 1 of the hierarchy, and yet have a very large memory as large as level n. So maintaining this illusion is the subject of this chapter. So although the local disk is normally the bottom of the hierarchy, some systems use tape or a file server over a local area network as the next levels of the hierarchy. Thank you.